A very good morning to all. I Miss Anagha Asgekar on behalf of Principal, Vice Principal and staff of Bharati Vidyapeeth College of Pharmacy Kolhapur would like to welcome you all for AICTE sponsor FDP on Nutrigenomics Unveiled Frontier in Healthcare organized by Bharati Vidyapeeth College of Pharmacy Kolhapur. It gives me immense pleasure to welcome our guest for today's function, Dr. Abhay Harsulkar. We really be honored to have you with us today. I request Coordinator of Program Dr. Firoz Tamboli sir to address objectives of FDP.
Good morning to all of you. Welcome today's chief guest, Dr. Abhay Harsulkar sir, Senior Scientist, Interactive Research School for Health Affairs, Pune, our beloved Principal, Dr. H. N. Mori sir, and Vice Principal, Dr. M. S. Bhatia. Well, welcome all participants from all across all corners of India. Thank you, ATAL Academy, for the financial assistance. The faculty development program has been initiated by ATAL Academy to facilitate upgradation of knowledge, skill, and provide opportunity for training to teachers. This will help to enhance the teaching and other skills of the faculty and to upgrade them on modern teaching tools and methodologies. Events like these will help support technical institutions in fostering research, innovation, and entrepreneurship through training. The purpose of choosing this topic is that the new science of nutrigenomics teaches us what specific food tells your genes. What you eat directly determines the genetic message your body receives. This message in turn control all the molecules that constitute your metabolism, the molecules that tell your body to burn calories or store them. If you can learn the language of your genes and control the message and instruction they give your body and your metabolism. So you can radically alter how food interacts with your body, lose weight and optimize your health. The basic, having understood the importance of nutrigenomics for teachers, we submitted proposal to AICT, our apex body, and AICT considered it worth. And today, what we have been gathered here is the result of it. The basic objective of these 5 days programs are to address basics, advances, application, and limitations of nutrigenomics development, to review and identify the potential thrust areas in nutrigenomics, those needs application of nutrigenomics and simplify its understanding, discuss and debate regulatory guidelines for nutrigenomics and its enforcement feasibility in Indian scenario. And finally, to orient faculty towards nutrigenomics teaching and research so as to produce trained, skill and component human resource meeting future needs. To achieve this, the entire session has been conducted online lectures. We have got total 14 deliberations from eminent researchers from the field of nutrigenomics. Beside deliberation, ample time have been reserved for discussion. So I am sure that this FDP will surely support roles of faculty members to improve their performance in education, research and administration as well as augmenting organization capacities and culture and build their students industry ready with required skills. Thank you.
Thank you so much, sir. Now I request our Honorable Principal Dr. H. N. More sir and our guest Dr. Abhay Harsulkar sir to inaugurate today's function. Thank you so much, sir. Now I request our Honorable Principal Dr. H. N. More sir to welcome and address today's function. Over to you, sir.
Hello, sir. Your mic is
Mute. Please unmute yourself.
Yes. Thank you, Anaga. Good morning to one and all. Today's chief guest and the keynote address person, Honorable Dr. Abhay Harsulkar, sir, Senior Scientist, Bharati Vidyapeeth deemed to be University Interactive Research School for Health Affairs, Dr. M.S. Bhatia, Vice Principal, Dr. Firoz Tamboli, Coordinator of this ATAL FDP, his team, and respected and dear delegates who have joined this ATAL FDP through online mode. It gives me an immense pleasure to welcome you all for this one-week faculty development program on Nutrigenomics, Unveiled Frontiers in Healthcare, sponsored by ATAL Academy, AICT, and organized by Bharati Vidyapeeth College of Pharmacy, Kolhapur. It gives me a proud feeling to say a few words about our Bharati Vidyapeeth College of Pharmacy, Kolhapur. Sir, and many of the delegates might be the alumni or the well-wishers of Bharati Vidyapeeth. And all you know that Bharati Vidyapeeth is one of the biggest educational institutions founded by Honorable Dr. Patangrao Kadam on 10th May 1964 with motto social transformation through dynamic education. And at present, there are more than 203 educational institutes imparting education right from nursery to PhD program. Bharati Vidyapeeth College of Pharmacy, Kolhapur is one of the 3 pharmacy colleges run by Bharati Vidyapeeth, Pune, which was established in 1996 and affiliated to Shivaji University, Kolhapur. We at Bharati Vidyapeeth College of Pharmacy, Kolhapur are conducting D.Pharm, B.Pharm, M.Pharm, and PhD program in pharmacy. I'm proud to say that since 2005, this Bharati Vidyapeeth College of Pharmacy, Kolhapur has been accorded the status of lead pharmacy college in Shivaji University. At the same time, the National Institutional Ranking Framework, NRF, by AICT, New Delhi, and Ministry of HRD, presently Minister of Education, Government of India, has incepted the concept of the ranking, India ranking, since 2016. And it's honor and proud to say that Bharati Vidyapeeth College of Pharmacy, Kolhapur has been consecutively ranked 6 times amongst the top 75 pharmacy colleges in India. And in NRF India ranking 2021, Bharati Vidyapeeth College of Pharmacy, Kolhapur has been ranked amongst the top 50, that is 49th rank in India. We at Bharati Vidyapeeth College of Pharmacy, Kolhapur are always keen in on-road development of the faculty as well as the students. And we are organizing various faculty development programs, workshops, seminars, and conferences for the development of the faculty as well as the students. And today's ATAL FDP on Nutrigenomics Unveiled Frontiers in Healthcare is one of its kind. Dear friends, you know that the excitement about the nutrigenomics comes from a growing awareness of the potential for modifications of food or diet to support health and reduce the risk of diet-related disease. It is an emerging field that tends to unfold the role of nutrition on gene expression, which brings together the science of bioinformatics, nutrition, molecular biology, genomics, epidemiology, and molecular medicine. It is understood that with the increasing changes in the food habits and lifestyle, people are becoming more prone to diet-related disorders. And in this context, I'm sure that this ATAL FDP will help all of everyone, all of us, in understanding the relationship between the diet and health. And I hope the deliberations from the various academicians, industrialists, and the researchers from this field will definitely boost or a good knowledge and understanding about the issues and the diet. I hope all of you will enjoy this FDP, which will be conducted from 23rd to 27th of November. And once again, I welcome you all and request you to participate with full enthusiasm. And also, I very much thankful to Honorable Dr. Abhay Harsulkar sir for accepting our invitation for today's FDP. Thank you.
Thank you so much, sir, for your valuable words. Now I kindly request Miss Asha Dado ma'am to introduce our guest speaker, Dr. Abhay Halsukar, sir.
Thank you, Anga. It's my immense pleasure to introduce such excellent and eminent speaker, Dr. Abhay Harsulkar sir. Sir has completed MSc from Marathwada University, Aurangabad. Sir has awarded his PhD in the
Asha,
Yes, sir.
Asha,
Yes, sir.
the name on the slide, just Radhakar, something wrong, went wrong.
Yes, sir. That should take Sorry for the inconvenience. It's my immense pleasure to introduce such an great and eminent speaker, Dr. Abhay Harsulkar sir. Sir has completed his MSc from Marathwada University, Aurangabad. Sir has awarded his PhD in June 1995 from Babasaheb Ambedkar Marathwada University, Aurangabad. Sir having vast experience in the field of academics as well as in research. In these tenures, Sir has worked as junior research scientist, senior research scientist at Babasaheb Ambedkar Marathwada University, Aurangabad. Sir has also worked at Nuclear Agricultural Division, Baba Atomic Research Center, Mumbai. Then he has also received the research experience from the National Chemical Laboratory, Pune, as a research associate. He has also worked as senior scientist at IRSA, where he worked in the area of nutrient gene interaction with the omega-3 fatty acid in the non-communicable disease. After this all, he entered in the academics as a professor and head of Department of Pharmaceutical Biotechnology, Pune College of Pharmacy, Pune. Sir has received approximate 372 lakhs of amount from the different funding agencies like DBT, DST, Tata Chem, etc. Regarding the research publications, Sir has published approximate 110 articles in reputed national and international journals with total citation of 1974 with the H index 25. With his brief introduction, I would like to request Dr. Harsulkar sir to start with your presentation. Over to you, sir.
Thank you. Thank you for the introduction and thank you for inviting me over here, um, Dr. H.N. More, sir, Principal, Pharmacy College, Kolhapur, and Firoz Tamboli and his team. Right, of course, I should, of course, remember Dr. Shivaji Rao Kadam and Patang Rao Kadam for founding all this family, Bharati Vidyapit family, right, and then allowing us an opportunity to work over here, right. So with this, should I start with my presentation straight away? Right?
Sure, sir. Sure. Sure,
Okay.
sir.
Um, I must congratulate the organizers for selecting this topic. Nutrigenomics is one of the upcoming branch of science because, as we all know, that nutrition is the most important part for our health being, right? And what could be other than a pharmacy college, right, to take these kinds of activities, right? So that is, I must congratulate the Firoz Tambore, his team, and the entire Kolhapur Pharmacy College team as such to have taken this an important topic for this deliberation today. Okay, so with this, can I share my content? Let me see if I can share. Okay. Can you see my first line?
Yes, sir.
Okay. Right. So today what I'm going to speak about is nutrigenomics and non-communicable diseases, right? And that is, we all know that the burden of non-communicable disease is increasing, right? And then it is one of the most important part because our life expectancy is increasing, right? Because easily now we have people who are like living over 70 years or maybe 80 years of age, and at that stage we have several different non-communicable disease incidences that is coming up, right? So with the expectancy is increasing, life expectancy is increasing, our burden for non-communicable diseases is also increasing. So that is one of the things, and therefore this is one of the very uh, important area to work with. And nutrigenomics is one of the is the next wave in nutrition research, like as it's been told by Dr. Tamboli as well as Dr. More in their inaugural speech, that the nutrition is how important that nutrition is. And I agree with them that nutrition, and correct nutrition rather, I should say, that is a key thing to maintain our health and maintain our well-beingness, right? So health and well-beingness are usually divided. They are two different things, but then being well or feeling well from within is a sense of well-beingness, right? So both the things would come from a good food, right, and good nutrition. So as we could see this into this, what is a nutrigenomics? So basically, we will look into that. So we have human genome at one sector, we have pharma sector at one hand, and then agriculture, food sector at the other hand. So the interface between all these three, right, different disciplines, right, pharma, human genome, and genomics, and agricultural and food. So that is one that where all these three meet. I think nutrigenomics is a area which is like coming up from there. So that is the proper area of nutrigenomics, right? So uh, we have a great tradition of food, right? So we have Ayurveda, of course. We talk about Ayurveda, but then we also have all food considered almost like another Veda, right? So we have a rich tradition of food, in especially food preparation, food consumptions, right? And then the food ingredients, or harvesting food ingredients, right? And then starting from there, right? So when to consume, what to consume, how much to consume, all we have a definite directions, right, given to us from our traditional knowledge. And therefore India can be a leader in this world for the food. So that is basic hypothesis that we look into that. Now, like, what happens with the food, right? Food is not like something, a dead thing that we are eating, right? So food is very much alive biochemically, and then it can act on this, on all of this, right? You could see that on your right hand side, what is known as central dogma of molecular biology, from DNA to RNA, RNA to protein, and protein to metabolite. That is how the flow of information goes, which we describe as transcription, translation, and metabolism. And bioactive food has a potency to act on every step of this central dogma of molecular biology. So we have got a food ingredients that act on transcription, which can modulate gene expression. We have food that can operate on translation. So even if the RNA is produced, right, and food ingredients can intervene between RNA to protein production. And even when the proteins are produced, we have got food ingredients that can modulate protein action, and therefore can change the metabolism in our body, right? So in our body, food can change metabolism from such a grassroots level, right? From our DNA to our protein, every step food ingredients can influence and can change those, right? So that is how it goes, right? So nutrigenomics is therefore a study of response of humans to food. So me and my food, see, my it is like my genes talk to my food, right, or my food talk to my genes, right? And that is the area of working of nutrigenomics, right? So it's like when we say genomics, proteomics, or metabolomics, that means it's a global approach to study, right? That omics stand for the wholeness, the totality, right? So the total of genome, total of proteome, and total of metabolism that happens in our body is responsible for the is an era of study in the nutrigenomics, right? So that is how the nutrigenomics has some part of genomics, some part of proteomics, and a major part of metabolomics coming into its area of working, right? So that is how. And an ultimate goal is to develop food that can be match to our individual genotypes. So if my genotype, so my superfood can be a poison to someone else, right? And vice versa. So someone's superfood can be a poisonous for me too, right? So between these two extremes, right, we operate, right? Because we know that in the pharmacodynamics, or what happens is, like, we are slow metabolizers, or we are a super metabolizer or hyper metabolizers of different things. So we do metabolize our food or food ingredients in a different way, right? And that is where our our, our individuality stands, right? And that is what we could say, that our food is our food, right? It cannot be everybody's food. So my requirements are specific, personalized, right? So what is we call as individualized or personalized requirement for food. So food is therefore is important. What is happening in the, there are two parts, right? If you see closely, the nutrigenomics, right? So it is nutrigenetics, right? So what is nutrigenetics? It is the genetics, that is my genome, right? So it is my own genome, my own genetic variation that is affecting that is affecting my metabolism. So it is part, one part is nutrigenetics, right? And then that is where you will stand lot of different opportunities, right? Where you will have a lecture, like one of my friend Amol will be speaking to you on nutrigenetics, where they can like know the SNPs. There are ways and find out the SNPs in your own gene, right? And then if you can identify those SNPs, those stands as a marker for your own composition of genetic, and then your susceptibility and influence to various different genes, right? So that is what, that is a part of nutrigenetics. So nutrigenetics is the genetic composition that I may have, and that is influence on my own diet, right? So that is a part of nutrigenetics. The another part is nutrigenomics, where how my gene expression is affected by different these things. That is what I work into it, right? So my work is especially into the application of genomics in nutrition research, in terms that we study various gene interaction, where how this thing happen into that. And in my like talk today, I'm going to cover some such part into it, like that how we study the influence of food and diet and nutrients on gene interaction, gene expression. And that is what we call as roughly as nutrient gene interaction, interaction thing, right? So that is what we look into it. So now food compounds, right? So our food composition, as I told you, work on these nutritional into the central dogma, and then into the genetics, proteomics, and metabolomics function. So I already have covered this slide, so that is fine. So what is an individualization? So that is very interesting part, that okay, if I as I told you already, that individually my genetic makeup, right, and my food, that has to match, right? And if it doesn't match, then you have lots of like food allergies or food poisoning, right? From there on to the benefit of food for curing, right? So for or preventing yourself from being susceptible for various different diseases. Like in this corona, you have seen that vitamin D supplement was very highly correlatable to the symptoms that you develop, right? So now vitamin D is also is also a nutrient constant, right? So you can obtain vitamin D from your diet as well, right? Of course, the sunshine is one of the important part, right? You cannot ignore that. But then there is some vitamin D that you can obtain through your diet as well, and that is where you need a supplementation, right? And that entire thing goes into individualization. So if I am unable to produce, like say suppose vitamin B12, B12 is a very common, but then B12 deficiency is also rampant in our population, right? One of the two important deficiencies that we face today are vitamin D deficiency and vitamin B deficiency. despite of our being facultative or obligate non-vegetarian or vegetarian, despite of that, we have to like, why this situation occur? Because B12 and vitamin D both are like essential nutrients, right? So we need to take them through our diet, right? D, of course, like we can get it from sunshine, but the sun exposure itself it's a compromised thing, right? So today we just move by car and then we are indoors, right, all the time. So we didn't get much time into sun, right? So that is where the vitamin D deficiency crops in. Vitamin B deficiency is there because vitamin B, although it may be there in your diet, but your absorption may be poor, right? And your absorption of vitamin B is determined by your individual genetic makeup, right? And those, and what is true with vitamin D and B may be true with many other things like omega-3 fatty acid. I'm going to speak about omega-3 fatty acid about that. So those are also essential nutrients and we don't get those, right? And if we don't get those, we are subjected to various different deficiencies and deficiency associated symptoms of these nutrients. So that is what we would look into it. So if you look into the trends of nutrition science as such, this is a little older kind of thing, a slide, but then it still holds true because we are like looking from general diet. That is what we talk about. Earlier we used to talk about like maybe a new food security, right? So the food security, that is the, we need calories, right? So that is like what we spoke about general diet, right? And how the general diet should be improved and things like that. Now then we got into a era of functional foods, right? So we talk about functional food, right? We talk about probiotic chocolates or probiotic ice cream, right? Those are all called as functional foods because those foods are associated with functionality, right? And then we are graduating into an era which is given in the circle, that is a personalized nutrition, right? Where we can like run tests on our genome, right? And then from genome we can analyze which food is best for us or what food we should take, and then uh, uh, we can arrive at a personalized complement of nutrition. And there are dietitians already out there who can who can do a genetic test on our DNA and then advise what nutrients we should take, right? And even in Pune, at least I know a dozen of such dietitians who prescribe a genetic test and accordingly then prescribe you the food. One good area is sports, right? So if you are into sports, for example, sports and nutrition goes well hand in hand, you know that, right? Already, that if you are like into a commercial sports, right, or into a competitive sports, then you are definitely has to look into definitely has to like have a dietitian who would advise you correct food, and that is how you would progress into it, right? Into that, for example, if you are a runner, right, just for an example, so there could be a sprint type and there could be a marathon running, right, are two different ball games. And then you have to like get a genetic test done, that what you are best for. Are you a marathon runner or you are a sprinter, right? Because sprinting and marathon running both are completely different metabolic activity, right? Your muscles has to have endurance. A muscle has availability of or metabolism of a particular a glucose and other energy metabolism, and that denotes if you can be a marathon runner or you can be a sprinter. So a sprinter cannot be a marathon runner or vice versa, right? So there are genetic tests which can be done if you to determine which sport you should choose, right? And those are according to your genetic makeup, according to your DNA, right? So that is what we can talk about. And then further we have to like speak about community nutrition, right? Where what happens is like at a community level, right? What happened, like why we are getting so much of a diabetes, right? As an Indian citizen, we should worry about that, right? Why we are become a capital of diabetics, right? Why we are becoming a capital of obese person, and then what is wrong with our nutrition into that part, right? So those are into community nutrition. So nutritional genomics goes into all these kinds of steps, and then we could see and experience that and become a witness that a nutrition science is progressing into all these kinds of steps, right? So that is what we could talk. So let's talk a little bit about human genome, because we cannot like when we talk about nutritional genetics, we cannot like escape talking anything about human genome, right? So human genome, you know that, okay, has been sequenced already, right? We have the 3 billion base pair sequences already with us. We have somewhere around 30,000 genes, right? And then we already know that, okay, we have 98% of our genome which is junk DNA, because we don't know what it is doing. That's why we call it as a junk, right? And then 2% of our genome is the coding genes. That is what you know about the gene. This is how our genetic complement is from chromosome 1 to 23 and our sex chromosomes, right? So that is how our genome looks like, right? As the chromosome. So these are the nature and science publications where the human genome has been published, right? In somewhere in 2000, right? And these are the Craig and Venter, right? 2000 on June 26, 2000, they declare the human genome has been publicly declared to be done, right? Completed, right? And that is where you could do that. But what is into your what is into your genes, right? If you look into your genes or this genome sequence, right? Not just genes, genome sequence, it is just AT and GCs all around, right? From start to bottom, right? From top to bottom and left to right, everything is like AT and GCs. And then how you would make any sense out of that? And that is what we are looking into it, like how the more we unfold this genome, it is the same thing all around, and that is confusing. Like we really don't know like how this how to decode this genome, or how to even read this genome, right? And that is the this cartoon shows that exactly what this that sentiment. So what we could look into through our genetic information is basically, of course, in our genetic information, there are a lot of things, but out of those, one very important part that concerns nutritional genomics is genetic variation. So we know that like our fingerprint is unique to us, right? Our genome is also unique to us. So there is no two individuals in this world who have exactly same genetic makeup, of course, like barring our classical example of identical twins. Identical twins have exactly identical genetic makeup, but then that is the only exception, right? No two, otherwise there are no two individuals who have the same genetic makeup. So we are, although we are 99.99% genetically identical, we, that means that we have 0.1% or 0.001% similarity between dissimilarity between us, right? So 99.9% similar, that means 0.01% dissimilar. But that 0.1% dissimilar is also plays everything into us, right? That's why we are all different. We look different, we behave different, we have a different metabolism, we have different genetic makeup, right? And that is because our genetic variation, although it looks like insignificant, it has a significant effect, right? So that is what we must understand. So so this 3 billion, so there are 3 billion or 3 million differences if you, on an average, if you take two individuals, right? Even if 99.9% are same, right? And then we still have lot of dissimilarities between that, and that dissimilarity comes from the SNPs, right? What is we call as a SNPs, or single nucleotide polymorphism. So what does that mean? So if you take your hemoglobin and my hemoglobin gene, and if you like match, it will be 99.9% similar, but then that 1% change denotes like one place you may have A and that place I may have G, right? You might think that it is just one base pair change, but how that is going to be different, right? How significant that could be to mind well that it is a significant difference even if there is one base pair change. Of course, like it depends on where the change is, right? But then the change is into exons, like are called a coding region of our gene, then it can have a change in our protein. So your hemoglobin protein may be different than my hemoglobin protein, and that can be, and then it may have an efficacy issue with those proteins. So your may have a better efficient hemoglobin than my hemoglobin. Obviously, you can run faster and longer than me, right? So that small variation, maybe if it is like 2%, maybe 3% efficacy difference between hemoglobin molecule, right, that you code and I code, that would make a difference when we are, especially as I told you, right, if you are a sport person, then that difference can be, that difference can be significant. Okay, so SNPs in intron region or regulatory region or promoter region of a gene, right? So what happens with those, then the level of expression of that gene varies, right? So you know that we all metabolize various different things, including our food and medicine, using cytochrome P450 genes in our liver, right? So we have around 25 to 23 cytochrome P450 genes, right, as such in our genome. But there are a lot of variation into it, right? There are a lot of SNPs into it, and those SNPs make you express a different complement of this cytochrome P450, and I can express a different complement of cytochrome P450, right? So because there is a difference between the composition of cytochrome P450 in your liver and my liver, we are different metabolizers, right, of our medicine or drug or even tea or even coffee, right? So you may be a fast metabolizer, I may be a slow metabolizer, and then depending on our rate of metabolism, our effect, the effect of those ingredients on our metabolism is determined, right? So you understand that. So that is where the SNPs would come into play and are responsible for the variation into our genome, right? So that is what we would talk about. So there would be like how many of these SNPs are there? Like, so around 1000 bases, there may be a SNP in our base, in our genome. Now I already have told you that we have 3 billion bases, right? So after 1000 base, if you can count that, it still be like more than 3 lakh places where your genome and my genome would be different, right, because of these SNPs, and that makes all the difference between you and me. So remember, our genomes are 99.9% same, but that a 0.1% difference makes you and me, right? And that is the key thing into our genome, right? So the seemingly insignificant differences in our genome can make us susceptible to different diseases, especially non-communicable disease I'm talking today, right? Obesity, coronary heart disease, diabetes, right? Prostate cancer, or various different cancer, or breast cancer, and everything, right? So that is the difference between the genomes and into it. One example I might quote about that, just to explain this, is like lactose intolerance, right? So there is a study published, right, about SNP into a CT13910 gene, which is 14 kilobase upstream to our lactose gene. Right now, this is not into the gene. Remember, so this is an upstream location. There is a SNP, and that is a regulatory SNP because that's where the promoter of our lactose gene, lactose hydrogenase gene, is located. And because of hydrolase gene is differentially expressed in us, we are susceptible to lactose intolerance, or we are very good metabolizer of lactose. So there are many people among us who does not have any problem with lactose, but there are individuals who have a serious problem with lactose. They cannot take milk because milk contain lactose, and this lactose can, if undigested, this lactose can give them a bad bloating, right? And they are susceptible for associated problems with the lactose intolerance. Right. One of the thing is here, like in Indian adults have 50% of Indian adults have this SNP. So 50% of our Indian adults may be susceptible for the lactose intolerance. Okay, so that is one of the thing that we talked about. We will look into that, how this food security versus nutrition security can be solved. Right, we take food, right? For example, earlier time, we used to, like, the food used to be scarce, right? So you could like just hardly meet two ends, right? To hardly make two meals per day, right? We have gone through that kind of situation. So but then the issue was, at even that time, what happened is you could get just two meals per day, but your nutrition was not a problem. Right, today what we have is we can eat at least four times a day, or intermittently also in between. Right, so we have a full belly food. No one on no one of us like goes hungry these days. Even then, our nutritional requirement is unfulfilled. Right, so it is a hidden hunger, what is called as a hidden hunger. Why it is a hidden hunger? Because my food belly is full, I'm not hungry, I have enough food, but my nutritional hunger is still unsatisfied. Right, my nutrition security is still unsatisfied, and I didn't get the nutrient required for my own thing. And that is our problem today. Right, that we have food enough, right, but we don't have nutrition enough, and that's why we still need to get supplements. Like, even after four times a good meal that you have in the day, you still are end up having B12 supplements, or vitamin D supplement, or micronutrient supplement, or a zinc supplement, right? Isn't it right? So we get enough of those supplements in the in a medical store around corner, everywhere in our country. And why we do that, right? And why that sale has gone up for the food supplements? And that's because people are getting aware that we are not being satisfied nutritionally. We may be satisfied uh, uh, as far as the food is concerned, right? No, as far as our our hunger is concerned, but then our nutrition is still unsolved problem, and that is where we need to look into it. And that is what the problem is. That, of course, like, we are like we undergo a lot of agricultural changes also, right? For example, in first generation changes agriculture, we used to breed for a high yielding varieties. You know that those who are old enough, like maybe around 50 years of old age, they know that, okay, what is an hybrid coming into it, right? And the versus the land races, and there was a debate, right? So there was a debate, like people would used to refuse to eat hybrid, and then they said Gauran is fine. So what is a Gauran? Gauran is basically what we refer to as a land races, right? And why land races are important? Because those are nutritionally important, right? Our forefathers been eating those two rotis, right, from all along, and then still be happy, right, and still be nutritionally sufficient. But today we are not sufficient nutritionally. That's because of this, because we bred our varieties for productivity, not for our nutrition, right? And that's a big gap between, right? We talk about green revolution. Green revolution fed us, no doubt, right? Thanks to all those who are involved into creating that green revolution in our country. But what was the problem? Green revolution only produce, right, only produce enough of food, but we never bred our varieties for enough nutrition, and that was a problem with in agriculture. So our agriculture go haywire, and that is where I just now, when I explain you situation where you eat lot, right, but you didn't get enough nutrition. Why? Because our food, our wheat, our rice, our jawar is not full with nutrients now, right? And that is our problem. So that is where agriculture is missing. Of course, like, there are some examples I'm going to quote that people are trying to do is, and one very vivid example is this golden rice, where it is going to, where there are three genes being used to transform into a rice variety to create a good amount of beta carotene in it, and that beta carotene gives this the appearance of golden color to this rice, and it becoming available for people to consume. And then when they consume this, right, they get enough of vitamin A, and that would be alleviate the eye problem, right, the visual problem with this, because vitamin A deficiency is give rise to a blindness, right, and that is where it is being productive. So this is one example, like how this thing can be done, right. One of the thing, another thing is like it is broccoli, but it's not just broccoli. Broccoli is which is rich in glucosinolate, contain quinone reductase, and this quinone reductase is triggers quinone reductase. So it contains glucosinolates, but of course our cauliflower also contain glucosinolates, right? So cauliflower or broccoli in your diet give you glucosinolate that trigger the quinone reductase gene in your system, in your liver, right, and that protects you from the unwanted cancer's growth, right. So it has an anti-cancer activity because of those, right. Flavonoids, we know that we have all studied flavonoids, right, which are coming in from various different teas, green tea and black tea, that what we call about is flavonoid rich, and that is an important antioxidant in our diet. Lycopene is another important, and then we have created a lycopene rich tomatoes, right. So tomatoes which do contain lycopene, but we have tomatoes which are even a higher content in lycopene, and that is important for and that lycopene protects our DNA from oxidative damage, right. So that is what is important for. Soybean is another example where which gives you beta glycinins content, and that protects you from obesity, right. So tocopherols, right, vitamin E is important, from which is coming from the oil seeds that that we consume, and those oil seed contains tocopherols, and it is important in maintaining the the hygiene, the health of our skin, right. So especially that is important, vitamin E, right, and longevity also, right. So that is vitamin E is important for. So these are all nutrients that is coming from our food, right. So there are varieties that is being prepared now for higher nutrition content and better nutritional supplement for us, right. So agriculture is also one important thing, because farming, right, both are the only P and F is a difference, and that is how close farming is. Like, unlike we consider that, but then we should understand that pharmacy and farming should go hand in hand. And one important point which put them together is nutrition, right. Because the nutrition, when we talk about nutrition must come from our agriculture foods, right, agriculture crop, and that is where we must be able to talk about. Now quickly I will go through the omega-3 fatty acid, that is what my own area of working, right. And then we have worked on omega-3 fatty acid, because omega-3s we popularly call omega-3s as endangered nutrients. Like, we have endangered species, like we have endangered nutrient, because omega-3 is being removed from our diet, from our food in earlier time, because those can spoil our food. Because omega-3s, as you could see here, the omega-3, especially DHA and EPA and even alpha linolic acid, right, they have three double bonds, right. Here we have 1 2 3 4 5 6 double bonds in DHA, and 5 double bonds in our EPA, and these double bonds are site of oxidation, and that's why they get oxidized, and oxidized omega-3 fatty acid give that rancidity, and so keeping quality is lower. And because their keeping quality is lower, people have bred varieties which are free from omega-3 fatty acids, like soybean, for example. But now because when you express that oil, when you extract oil from soybean and put it into the cans and sell it into the market, right? So so that point of time, right, that's a good time elapsed into it, and it can get oxidized, right? And then if it become rancid, then it is of no use, then consumer won't take it. So this omega-3 fatty acid has been removed from the from those, and that is what will see that it become a endangered nutrient. And that's where my efforts was to clone these genes of omega-3 fatty acid and put it. So I will go through that journey, how we will do that in a quick succession. But then what we try to look into is omega-3 fatty acid, increase of omega-3 fatty acid in our diet. So omega-3 fatty acid, as I told you, is an essential nutrient. DHA is essential for our brain development, especially in fetus, because our brain is almost 60% fat and 30% of it is DHA, and 30% of it is arachidonic acid. So both are important fatty acid for us. So you can imagine DHA and IQ is correlatable, right? So those mothers who take DHA as a supplement when they are expecting, right, then their children come out to be a better they come out to have a better IQ, right, in their adult life. So it is therefore an important nutrient for brain development. So that is what we know. EPA is important for so many different diseases, especially coronary heart diseases. EPA should be important, right? And then ALA, we get it from the alpha linoleic acid, that is what we get from the flax. Okay, so what are our sources of omega-3 fatty acid? Earlier, fish oil, that is what we talk about. Fish oil and flax oil are our sources of omega-3 fatty acids, and that is an important thing to look into, right? So those are important sources of omega-3 fatty acid in our diet. Which are those? Fish oil, flax oil, and green leafy vegetables, right? So we took those, right, for our better health. So fish oil, of course, fish contain omega-3 fatty acid, uh, but then those are deep sea fishes like tunas and salmons and things like that, right? The fish that we consume here around Pune or around Kolhapur or in Maharashtra, right, are being caught from the fresh water, right? And then ours is a hot country, so our fishes don't contain so much of omega-3 fatty acid. I don't say that they don't contain at all, they do, but then it's not like an rich in omega-3 fatty acid, right? So that is with our fish, right? And how many times you eat fish per week, right? Maybe once, or maybe even not that much, right? Flax oil used to be our day-to-day consumption oil, but then where is flax oil now? Right, we don't use it now for our cooking, of course. Like, why? Because it contain alpha linoleic acid, and it can get rancid, right? And it get a smell because of its rancidity. But flax oil is also not there in our diet these days, right? Green leafy vegetables, you can ask yourself how many times you eat green leafy vegetables per week, right? And if it is low, right, less than three times per week, then you are basically on a low consumption of green leafy vegetables. So where are you getting omega-3 fatty acid? That's why we call it as an endangered nutrient, right? So that is what we talked about. Right. So we have got a polar bears who are eating salmons, and they say salmon is good in omega-3 fatty acids, right? And then, and of course, like, it contains heavy metal contamination that can also become a problem. So there is a rationale that you have to exercise before you consume your omega-3 fatty acid, and then come out with the health benefits out of that, right? So we so the point is, we don't have a good source of omega-3 fatty acid, and that is where we started working on flax, and that is we talked about, and that is where we are important. This is another important slide, in the sense that even if we cannot convert, because if we do have a lot of omega-6 fatty acid in our food, right? But then that omega-6 cannot be converted into omega-3 by our liver, right? And that is one of our limitation in human physiology, right? We have lost that gene in our evolution, and that is why omega-3 fatty acid is an essential fatty acid. We have to consume it in our diet, right? And that is the omega-3 sources were better, right, when we were hunter and gatherer, right? But then when we become an agriculture society, that then also it was better. But then if when we become an industrial an industrial person, right, then after industrial revolution, the omega-3 fatty acid has gone down. If you could see that, this is the line where omega-3 N3 is an omega-3, so which is declining and coming down. N6, which is omega-6, which is going up, and trans fat has really jumped up after industrial revolution, right? So our consumption of trans fat has increased, and that is where it is being toxic. And if you could see that, in fact the total fat consumption has jumped up too high after we become industrial person, right? So after industrial evolution, our so what happens is, this slide is interesting in a point that you must understand that our genes are not going to change within like 100 year or 200 year or 300 year. Our genes are still the same as when we were hunter or gatherers, right? And those genes now, we have those genes, uh, but now are after this industrial revolution, if our food habit changed dramatically, then we are at a problem. Why? Because our genes are still as like an hunter gatherer, right? And our food habits are now changed. So now the hunter gatherers don't used to get so much of calories. So now we take a lot of calories. Like if you are eating a cup of ice cream, you can imagine how much calories you are consuming at one point of time. Are our genes suitable to tackle with those many calories at one time? The plain answer is no, right? Because our genes, which are like from hunter and gatherers time, does not allow us to take that much calories at one go, right? Why? Because the calories are less available as a hunter gatherer. Every single extra calorie is converted into fat, right, and stored in our adipose. But today what happened is, we have too much of calories, and all the calories our body converts into fat and stored in our body, and that is where the obesity lies, right? So this mechanism, this metabolism to convert calories, extra calories which are not consumed, into fat and stored in adipose, was a suitable adaptation as for a hunter gatherer, and we still carry that up, right? And we still have those genes, right? And that is a problem, why we are getting fatter and fatter, why we are getting obese, right? So this is a very interesting side from that kind of thing. Okay, so omega-3, as I explained you, has been removed from our food stock. So our milk used to have a good amount of omega-3, but today it is not. Why? Because when now our cows and buffaloes don't go into the green pasture to eat green grasses, right? They are stall fed, right? We feed them omega-6 fatty acid in terms like, okay, we the cake, right, after extracting oil, that is being fed very commonly, really routinely for our milk animals, right? So they do contain omega-6 fatty acid. So where omega-3 fatty acid is going to come in their milk, right? So milk used to be a good source of omega-3 fatty acid, but now not, right? Similarly, meat and egg, right? When the hen are eating freely into the environment, into the and then eating food, picking up by its own, then it was fine. Then it would have some insects, some green things into a hen's diet. But today's hens, we don't allow them to move around, right? We just feed them a pelleted food, and a pelleted food contain lots of omega-6 fatty acid. So now the eggs also contain lot of omega-6 fatty acids. So they used to contain omega-3s, but they don't have now, right? But then the flax is the only thing. The fish I told you about, the fish is good source, but we don't get deep sea fishes here. So fish is neither an option for us. But then a flax is, right? Why flax? It is an important thing for us, right? So this is basically we talked about EPA and DHA, importance of that, and that's a balance between the health. So what happens is in our body we have inflammatory and anti-inflammatory processes, that is those goes on, and those need to be balanced, and if that balance is tilted towards omega-6, then we are going to face these diseases, and that is what is we are really facing up, right? And that's why the omega-6 or the non-communicable diseases are coming up. Okay, so one of the important thing that we must understand that omega-3s are nutrient, they are not medicine. So it is not that okay, you have a disease and then you switch on to omega-3 fatty acids. No, the omega-3s need to be in your diet when you are healthy, right? And then that would prevent you from the occurrence of diseases down the line, right? So those are nutrients, not medicine, right? And in those cases flax, right, that is javas, is an important thing that we must consume in our diet on a ready basis, right? So that is the sense that what we are talking about. This is flax, right? I'm sure everybody knows flax, right? We have seen that this is beautiful flower of flax. This is a field. This is our field. We used to go to Nagpur to grow flax there, right? And that is where we used to go flax. This is the flax seed which we get into our that. So why what is that we should do from the flax, right? So that is where we looked into it. So these are our omega-3 content of our usual oils, right? Say suppose we are using a common oil that we use is groundnut, safflower and sunflower. So the middle three one, and then you could see that there are no omega-3 fatty acid in them, right? And then omega-6 fatty acid is very high, somewhere around 30% in groundnut, 75% in safflower, 60 to 65% in sunflower. So we took very high amount of omega-6 but no omega-3, right, when we consume our oil. So that is an essence. But when you look into flax, for example, it contains almost 58% of omega-3, right, and 14% of omega-6. So when you increase your flax oil consumption and decrease our consumption of groundnut, safflower, sunflower oil, then what you could do, achieve a balance, right, between omega-3 and omega-6. Remember I told you omega-3 and omega-6 are 1:1 proportion in our prehistoric diet, right? And today how much it is? 0 is to 75. Could you see it here, right? 0 omega-3, 75 omega-6. So that is where we are landing in a problem, right? So that is how we perceive this in Irisha and started working on that, and that is where we look for the genes to use those genes to convert omega-3 into omega-6 into omega-3. This is the pathway that we studied, and me and my team started working on that, and we could see that the delta 6 desaturase and delta 5 desaturase, these are the genes of target, and that is what we should do. And then there are delta 15 desaturase, right? That is what happens in the plants. So in the flax what happens is oleic acid is converted by delta 12 desaturase into linoleic acid. Linoleic acid is omega 6, which is further converted into flax by a gene called delta 15 desaturase, which is not there in safflower, which is not, this gene is not there in sunflower. So sunflower stops here at omega 6, right? They contain a lot of linoleic acid, but flax goes one step ahead, convert this omega 6 linoleic acid in alpha linoleic acid, and that is where this gene is important. Which one? Delta 15 desaturase gene, and that is where we started working on. So we collected a lot of different delta 15 desaturase gene sequences from the from the databases, aligned them, right, and then found out which are the conserved domains into it. These are the conserved domains into that. So from these conserved domains, we constructed the primers, right? And then these are the primers that we constructed, and then we, because this motif is the conserved motif into this gene delta 15 desaturase I'm talking about. So delta 15 desaturase, this sequence like FLV, GHD, CGH, GSF, that is the protein sequence, right? And these are the primers that we constructed from that, and we use those primers to to do PCR, right? So from flax